Hello everybody, it is Mike Levin on Monday, February 21st. Happy President's Day. And today I will be finishing a project from the other day where I started to create a concurrent crawler, a one-page crawler. Really, you feed it a single URL and it comes back with a list of links. That's actually up here. That's this thing here, extract links. And that'll give you a list of links, and given that list of links, you can then crawl each page, each link that you find. So without further ado, let me restart the kernel, clear all outputs, and start from the top. A cell for nbdev autodocs, a cell for nbdev default file names, a cell to turn on the black pip8 code editor, some documentation, the pip installs that are required, the imports that are required for all this stuff. And now the functions that are exported to the package, these are exported as well. So far there's 2 cells that are exported to an external py package. And now a few tests to assert things about the system. Assert. These are real honest to good tests, which I believe GitHub continuous integration will run whenever you get push. And if there's a problem, it'll email you. Again, thanks to nbdev. Now we go to that sample page, my home page, Mike Levin, mikelev.in. And we grab the links off that page. That's basically just visiting that one page. If we were to look at it, you would see a whole bunch of links, which are the links found on my site's homepage. How many are there? Whoops. There are 712. This was my old sequential way of crawling those pages, and it took minutes. So I don't even want to run that by accident. So I have that set to raw, similar to the database call that plugs it in to the database. That I have set to raw so I don't run it accidentally. This was just some stuff left over from showing you how I'm going to make this support tuples. Right now, if tuples it'll just pass. But if it's not, and it's a list of actual URLs, well, it'll check if they're good URLs. And if they are good URLs, it'll execute a concurrent crawl of all of them. Now, the stuff that was different from last time is that this RESPS here, I was really just returning that. And that was giving me a list of return values. In fact, I should do a before and after before I show you this change that I've actually already made, because this is kind of pulling it out of the oven. First, I'll show you the problem that I had. So the return value is being set to this await statement of the gather, of the fetching of all these pages. And then the return value is returned here. So I'll put that in memory. And here we are simply calling it with that list of links from above that I showed you. And we're timing it. And it'll show us how long it takes. It won't be very long. It's really quite nice. I think there 5 seconds. It was taking 3 seconds before, so give or take a second. We can look at those values and we'll see they are all these lovely request-like response values. It's actually HTTPX that I'm using, but it has almost the same API as requests. You almost use them interchangeably. And getting this kind of performance of 700 some pages in 5 seconds is the reason I'm using this library. So that's really good. And if I wanted to see the URLs that were in here, there's URLs embedded into each one of these response objects. But they were provided on input. I'm actually sitting on top of this, the list that went in. So you remember that links here? So it seems silly to me to have to rely on something that's coming from out of the output. What if something went wrong and it's not a response object here? You want the original URL at the beginning of each item in this list. So instead of a list of response objects, it's going to be a list of tuples, the first item in the tuple being the input and the second item in the tuple being the response object, like you see here. So that turned out to be just this really simple line. I was doing it another way here. I deleted out all the, you know, the work in progress, but I basically had this tuple command outside of here. And I actually first tried starting doing this in another way. It seemed to me that whenever you have list comprehension, what you really want to do with list comprehension is turn this into a tuple and then do rec, comma. And so rec, comma, and then the output of a function that calls rec for rec in recs. That, in my mind, is how list comprehension works. However, we get this error, async IO future, a coroutine or awaitable is required. See, so we can't really use a tuple in that location, and that was tripping me up. And then I, of course, knew that, you know, zipping after the fact was an answer, but that makes the syntax that you use out here, you know, ugly. You have to take vals, and then you take your input links, and you basically do this, you know, zipped vals equals making a tuple out of the zipping of your input and your output. And so that would actually work, except then you'd have to call this convolution every time you wanted that structure. But I want it to work this way by default, keeping keys and values coordinated for the upcoming insert into the database, that where they should be zipped together at birth, such as it were. And so that's why I moved that zip command up in here. And I had to make myself believe that doing this was safe, that I would actually be keeping in coordination a one-to-one relationship between the recs coming in and the responses coming out. See, because there's an issue here. RV equals, I gotta make sure I'm doing this right, because RV, see, where's recs? Oh yeah, there's resps. Yeah. So this is how it's actually going to be, because, you know, this is getting fed into there. And then this is just a simple zip statement, just like the one I showed down here, except it's up and inside the function. So without further ado, whenever you do stuff like this, it's nice to restart the kernel and clear all output. Some people have it so that it runs all cells, but I like to get down to a certain point. I often count these clicks, right? And as long as you have the somewhat damaging or weight causing cells turned to raw, you can just run right over those. You can run over these things. It's not going to do anything. Get that in memory. We don't really need to show our links again, but this is it. If this works, if this doesn't generate an error, this is a great, you know, success. So 4.5 seconds. What is in vals? And remember, we just did a kernel restart and clearing all outputs, so this is fresh. I got a few 301s in here I'm going to have to adjust, but all the rest, see that? URL going in, response going out, all the way down through all 713 or so URLs. And they are perfectly coordinated, the same amount of response objects as zips. Now that I'll keep an eye on, because if there's errors and stuff, I need to make sure this fails rather than getting these rows and getting things out of sync. That would be horrible, because then the URL would no longer be aligned to the, you know, response object that came back for it, and there'd be data integrity issues. So I'm gonna, you know, very alertly make sure that nothing ever gets out of sync, that this is actually a solid method. And that is a question or a function of really how gather works. If gather always gives exactly the same amount out as the inputs going in, right? Because this is a list, right? It's working off of recs coming in at the top of the function. It's a list comprehension, rec for rec in recs. But in list comprehension, it's also doing the HTTPX fetching of the HTML of the page, and this asterisk is splatting them as separate arguments into gather. So that seems pretty reliable to me. There's some parameters that can be used on client get here that handle errors, that control allow, fail, kill the whole job if a single URL fetch fails, that kind of stuff. So yeah, that's really solid. That's good. This is mission accomplished. And that means I take this function here and I move it up. I should do a cut. And I move it up now to this area where stuff is getting imported, and I will always, or getting exported to the package. I'll demonstrate that because it's going to take a while to grok NB dev. It's really a whole new way of working. I run this. You see that extra space put in. The black code formatter is working. I'll have to put some doc strings in there. This really is going to require some documentation. I have to decide whether I'm happy with this long name, async underscore get responses. You know, I'm going to be using this so much, and I have to choose between literalness, verbosity, long and precise, perhaps memorable, and short and snappy and nicknamey. I could use something like, a sync get, SYNCGET, sync get, async get. I can always use aliases and stuff, wrapper functions, decorators. There's lots of ways to handle that. But for right now, I'm going to go with this because it is so solid. Now that fetch is done. That's actually sitting there in memory. How long does it take to put those into the hard drive? So as you may recall from the past, I have this 12 gigabyte file sitting here, just a.db. It's a SQLite file. I'm going to delete that. It wasn't gigabytes, it was megabytes, 12 megabytes. My site isn't really that large. So let's put that back by just running this, and it's just spinning through, showing how many bytes for each URL. As usual with Jupyter, we get the asterisk here while the cell is running, and there it stopped running. And I can scroll to the bottom to see how long that took to drop 713 URLs into the database. It took about 7 seconds. 700 URLs, 7 seconds, 12 megabytes. That file is back. So we know we've done it. I did a one-page crawl, and that's pretty much it. Oh, I guess one of the things to point out here is that the elegance of this putting it into the database now is extra special, because for a tuple in vals, and then the key becomes the first position of the tuple, and then the data becomes the second position of the tuple. So I think I'm going to simplify this. A tuple is too long. It should just be tup. For tup in vals, print tup0. Print length of tup1.text. That's the length of the view source HTML. And in fact, I could even do a little bit more for tup in vals just to make it clear. The key is tup0. And the data is tup1. Or technically the key, and it's the response object. So, and now we can print the key. And now we can print the length of the response object text. See how it's starting to make so much more sense here? It's just clear. We put the key in here for the database, and we're setting that equal to the response object. We're committing it, and there. Look how beautiful that is to read, right? When we're talking about YPython here, it's almost like you're not coding in a programming language, right? Look at this. I mean, how much less programming-like can things become? How much more understandable could a process possibly become than this? It is beautiful, And I'll probably move on to handling that portion of the function that has to handle if a function is given, because it not only is a URL fetcher, but if your requests are tuples or name tuples, it will also do something like what's going on here. I'll be making another code block similar to this, but that does the special handling for tuples as your keys. I demonstrated that in the last video, because tuples are not strings. Because they're not strings, they need special handling to be used as database keys. They need to be pickled. So anyway, let me see if anyone on the live video is there talking or chatting. Yeah, not a big day for this middle of President's Day. People are probably out doing actually interesting things. But that does it for that. I'll be coming back, mission accomplished on returning zipped input output promises on an async Python function. This makes using it for key value database recording very easy. Next step, handling a list of tuples as input instead of a list of URLs. All right, so I'll probably do that video next. I feel that coming up. So